So the first thing that we did in these sections was just talk about identifying some things. This is asking several questions here, so this would be worth several points. The first thing it wants you to know is to state the possible number of real zeros, the possible number of positive and negative zeros, the set of rational zeros you could have, and then find all of your zeros. And you'll notice it says that one of those zeros has been given. So we're just going to list out what it asks for. The number of real zeros, that's the first thing it's asking. The number of real zeros is always your degree. All right, so this is always the degree of the polynomial. So I'm going to look at this and I'm going to say the degree of my polynomial is 3. Positive and negative, this is where we count the change in signs. So positive and negative zeros. The possible number of positive. This is where I count my sign changes. All right, just the way it is. And so I go positive to positive. Nope, it didn't change. Did not change, did not change. 0 times did I change signs. The number of negative is similar, but I have to plug in a negative and see what would happen. So plug in a negative and count your sign changes there. So anywhere there is a odd, it's going to change from the original. So this 2x cubed was originally positive. It's going to change to negative. This x squared will remain positive. This 34x would go from positive to negative, and the 24 would stay positive. Now I'm going to count again. From negative to positive is 1. Positive to negative is 1. Negative to positive is 1. My possible negative zeros here is going to be 3. So when I've listed them all out, these are all my factors of 24 over 1, factors of 24 over 2. And if they reduce to something I've already gotten, you don't have to write it again. All right, that's my possible ones. The next piece of this says find all zeros, 1 has been given. All right, so if I am writing down all the zeros, I'm going to start with the one I already know. They have given me one of them. One of my zeros is -2. That's easy. What do I do with him? Well, I'm going to use synthetic division and divide by him. All right, so I'm going to do synthetic division. Remember, if they give it to you like this, you do not change the sign. So I'm just going to use the -2. Make sure you've accounted for every exponent from the highest to the lowest. So I have 2x cubed, 15x squared, 34x, and 24 as my constant. And then I'm adding down and multiplying up. So add down, 2 plus nothing is 2. -2 times 2 is -4. Add down again, 15 and -4 is 11. -2 and 11 gives me -22. 34 and -22 give me 12. -2 and 12 give me -24. 0. All right, remember, if you don't get a 0 there, you did something wrong because they told you -2 is a 0. All right? So now I'm going to take this and I'm going to put my variables back in. I have 2x squared now, dropping it by 1, 11x, and 12. You can use quadratic formula all the time if you're good at quadratic formula, or you may factor. This is factorable, so I would personally factor it. All right, remember to factor. 2 times 12 is 24. Factors of 24 that add up to 11. What are my factors of 24 that add up to 11? Right, 8 and 3, hopefully. So I'm going to rewrite this middle term with those factors. I have 2x squared plus the 8x plus the 3x. That makes up my 11x. And then plus 12, right? Once I've broken it into 4 terms, what's my method for factoring 4 terms? Grouping, right? So I'm going to group the first 2 and the second 2. What do 2x squared and 8x have in common?
The 2x.
They have the 2x. I've taken a 2x out of this. I'm left with just x. 8x divided by 2x is just a 4. In the second group between 3 and 12, 3 is in common. 3x divided by 3 is x. 12 divided by x is 4. These should always be the same if you did it correctly or if it's factorable. So I have x plus 4 as one of my groups, 2x plus 3 as another one of my groups. Now I can find the other 2 zeros. I'm going to set each of these equal to 0. X plus 4 equals 0. That's going to give me negative 4. And 2x plus 3 equals 0 is going to give me negative 3 halves. And you can look, negative 4 was an option when I gave that pool of numbers, and negative 3 halves was an option when I gave that pool of numbers. So now I have answered every piece of this particular problem. Make sure you list it out and that you have accounted for all the pieces that it's asking for. Function, it says identify the points of discontinuity, which are your holes and your asymptotes. So on your quiz, it's actually going to list it like it did on the handout that I gave you. It's going to say holes, vertical asymptotes is what it's going to ask for. Horizontal asymptotes and intercepts. So it's going to ask for all of those. All right. So remember, the first thing I want to do is I want to factor these. Factors of 3 that add up to 4, that's pretty easy factoring. Factors of 6 that add up to 5. So the first thing I'm going to do is just write out my factored form of that so I can easily see the answers to these questions. All right, I'm going to start with the holes and the vertical asymptotes because those come from my denominator, all right? So remember, holes happen where I can cancel a problem in my denominator. So is there anything in the denominator that can cancel? Yeah, it's the x plus 3. What would cause a problem for x plus 3? What number? X equals what?
Negative 3.
Negative 3. That's where my hole is. And to find the y value of my hole, I would take what would happen if I canceled it. So if I canceled, I would be left with x plus 1 over x plus 2, right? That's what would happen if I canceled my problem. Now plug in that number that caused the problem originally. Negative 3 plus 1 over negative 3 plus 2. So I have negative 2 over negative 1. So my hole is actually going to happen. This is not part of your hole. It just helps tell you where it happens. Your hole is actually going to happen at negative 3, 2. All right, that's where your hole is going to happen. The vertical asymptote happens where it does not cancel on bottom. All right. So now I have the x plus 2 that will not cancel. So I have a vertical asymptote at x equals negative 2. That's a problem in the denominator that does not cancel. Okay, it does not cancel. So if I graph those, I'm going to go to negative 2, and I am going to graph a dashed line. Remember, it's not part of your graph. It's just a directional line. I'm going to graph that here, and then I'm going to graph that hole so that I have both of those already on my graph ready to go. All right, so I'm going to go to negative 2 and graph. And then I'm going to go to this negative 3, 2 and put a hole. All right. And then if the degree is the same, I'm going to use the coefficients. So I'm going to say if the denominator degree is bigger, that's going to go on your x-axis, y equals 0. If they're the same, like they are here, I'm going to look at my leading coefficients. So my leading coefficient, or the number in front of my x here, is a 1. The number in front of my x here is a 1. So it's going to happen at 1 over 1, which is just 1. So, and this is always a y equals, because I have a horizontal. Just the term horizontal means it's y equals something. So to graph that, I'm going to go to the value 1 on my y-axis. And that's going to be another dashed line. It's not part of your graph. It's just directional. All right. And then let's look at intercepts. Intercepts are kind of their own little thing. So for y-intercepts, it's really simple. You plug in a 0 for every single x. Everything's going to zero out except your numbers that don't have an x. Then just reduce if you can. 0, 1/2, plot that on your graph. 0, 1/2. For your x-intercept, and you can have more than one x-intercept, but for your x-intercept, you're going to look at your numerator. So what makes your numerator equal to 0 but does not cancel? Okay, so we're going to look back up here and we're going to say, okay, my x plus 3 canceled because it was a whole. What was left over on the bottom was my vertical asymptote. What is left over on the top is my x-intercept. So my x-intercept is going to be what happens when I zero out my top, as long as it hasn't already canceled. There's only one group left that hasn't canceled. That's x plus 1. So I'm going to have an x-intercept at -1. It's what makes it 0. So -1, and my y value is always 0 for that. So I'm going to go to the point -1, 0, and I'm going to plot a point there. I have answered every single question. All I need to do is sketch it, okay? This one is beautiful to sketch because I know exactly where this is going to happen. On the left side of my vertical, I already know it's going to be up here because I have that hole, which means it has to go along to that hole and then go past it, right? Down here, I have these 2 points, so I know it's going to graph down here because in order to be a function, it can't be both places, one or the other. So to sketch this, I'm just going to do that curve on this side here, and then over here, I'm going to have the curve doing something like that. And that is sketching my graph. They have given you your zeros. Remember, this is always opposite. So if I have a 0 that is a 4, which is what they've given me here, I'm going to say, well, x equals 4. That's my 0. Now I need to make this guy equal to 0. Well, what would I do? I would move that 4 over, subtract it over, x minus 4. That's how I would do that. And that's going to give me my binomial that I use to FOIL. I say that because if you were to have a fraction, and I don't know there's any fractions on here, you would do the same thing. You would multiply by the denominator and then subtract. So I have a 0 of 4. That gives me an x minus 4 group, but this particular one happens twice. How do I know that? Well, this little word right here, multiplicity of 2. So I have 2 of those. -1, what does that look like? X plus 1, right? It's always opposite of what you think. And so those are my 3 groups. To find the polynomial, I literally just FOIL, and it does not matter what order you FOIL in. Yes? Positive 8x and then plus 16. So I am just foiling 2 of them, getting that answer, taking the next one, distributing it through. Once I have distributed both pieces, all I'm doing is combining like terms. Once I have it as simple as possible, meaning I cannot combine any more terms, that is my answer. Okay, the main difference between that one and 17 is that 17 has a radical and an I. Anytime you have a radical or an I, it's going to pair up with its opposite, okay? So this square root of 5, well, I would say x minus the square root of 5. If you have that one, you will always have x plus the square root of 5. They always pair up. Even if they didn't give it to you, they always pair up. If I have the negative I, which is x plus I, I'm always going to have the opposite, x minus I. Okay? Now, when I have something like this, I always FOIL the two pairs, because that's an a plus b and an a minus b. So, but what I mean by that is when you have 2 of the same terms and it just looks like this, it's always going to FOIL to the first one squared minus the second one squared. It's a really nice, beautiful foiling Your middle term will always cancel on those. So if I were to FOIL this, it's going to be the x squared minus, what is the square root of 5 if I square it? What if you square a square root? You just get what?
Minus 5.
What's inside? All right, so that's a really easy foiling when I have those conjugates paired up like that. Same thing for the second group. I'm going to square that x squared, always subtract, and then I times I is I squared. What is I squared?
Just 1.
Negative 1, right? And so if I replace this with negative 1, I have x squared minus 5, and then x squared minus a negative 1 plus 1. And then I just have to FOIL those two, which again is a much easier foiling, right? So if I were to FOIL these, x squared and x squared give me x to the 4th power, x squared and 1, negative 5 and x squared, negative 5 and 1. And then I am going to simplify that by combining my like terms. X to the 4th minus 4x squared minus 5. And then I'm done with that one. So the radicals and the i's actually end up being rather easy to FOIL because they pair up so nicely. So first of all, you'll notice this does say check for extraneous solutions. All right, and so that means when you get to the end, make sure you don't have something that causes a problem. Also remember with these, really the only thing you're looking for is what causes a 0 in the denominator. So you can even at the very beginning look at it and say, okay, I know for a fact that x cannot equal 0, right? And so then you can have that in the top of your mind when you go through the process. So if you get 0 as an answer, you already know that that's going to be an extraneous one. The rule here is to look for the common denominator and then multiply everything by it. When it's a monomial, meaning you don't have a plus or minus, that's nice. You don't have to worry about factoring anything. So for this one, I look at a squared a. Well, my common denominator here is just a squared. And so I am going to multiply everything by that a squared.
Only a squared?
So, yep, because a squared takes care of all of them. So I'm going to multiply this by a squared, this by a squared, and this by a squared. So if I multiply the first one by a squared, both of these are just going to cancel to 1. And that gives me just a 1. On the second one, only one a will cancel. So the a in the denominator will cancel, but only one a up there will cancel, and I'm left with 6a. And then if I look here, a squared and a squared will cancel. I'm going to be left with 3. And then I have a really easy equation to solve, right? I'm going to subtract my 1 from both sides. I'll get 6a equals 2. And then I'm going to divide both sides by 6. A equals 1/3. I've already established the only thing that could cause a problem is x equals 0. I did not get x equals 0. So I am good with just x equals 1/3. All right, so for this one, it's not a monomial. It is binomials, actually. You could have a binomial, trinomial, whatever. So my first step really is going to be to factor it. I'm going to factor those denominators first. So I'm going to look at this and say, well, in this first group, an x can come out, so that's x and x minus 2, right? In this next group, an x can come out, and I have x squared minus 4, but that factors to x plus 2, x minus 2. Right? And then the last one can't really factor, it's just x plus 2. And so this one's a little bit different when I find this common denominator. If I'm looking for the least common denominator, I need to use at least one of each of these. So I'm going to use an x. That's going to be part of it. I'm going to use an x minus 2. That's going to be part of it. And I'm going to go to the next group. I've already accounted for the x. It's just to the first power, so I'm good. I've already accounted for the x minus 2, so I'm good there. I need to add the x plus 2 to my common denominator. All right? In the third group, I've already accounted for x plus 2. Okay? So when I look at this, I'm going to take this whole group here, and I'm going to multiply each piece by that least common denominator. All right? When I multiply this first group by that, the x and the x minus 2 will cancel, right? So if I multiply this first group by this common denominator, right, you can see that the x will cancel and the x minus 2 will cancel. And so my whole denominator has now canceled, and I'm left with this x plus 2 and this x plus 1. All right? Then I'm going to make sure that I put this equal sign because it will get lost in the mix. All right? When I multiply this next group by my least common denominator, that's actually the whole thing, right? So this I've already factored, so this whole thing's going to cancel, and I'm going to be left with just the 1. Don't forget you have a plus sign. And then if I multiply this third group by my least common denominator, the only thing that cancels here is going to be the x plus 2. And I'm left with a 1, which doesn't affect anything, times the x minus 2. So at this point here, I'm literally just foiling, moving things over to one side. My x squareds cancel. This is basic solving of equations. And then I check to make sure that it was not a problem with my denominators.